Hey everybody, welcome back into the next in our exciting video series on C++. It is I, Mr. Ensminger, here to talk to you today about structs and functions and how to use them together. In our first class this week, we are going to learn what a struct is and how to create it. And so we'll sort of overlap that knowledge with what we're doing here today in this video. So first, we are going to need a struct. I'm going to create a struct called student. And, like variable names, they have a conventional way of naming. They should be lowercase, then use camel style from there. Function names, same thing. They should begin with lowercase, camel style from there. When you create a struct, and what we'll do in the future, what is called a class, to set them apart, you should create those with capital letters. So you see there, take notice, I put student with a capital S. Inside here, we are going to put the members of these structs. I'm going to create a last name, first name, and grade level for my students. And because the last name, first name, those are strings. I know we haven't really done this officially, but as we move on into the latter half of the year, let me just throw this out there for you. You can have string. It's not technically a primitive type like integers, doubles, chars, things like that. But in this version of Visual Studio, it should work okay. And I know it's yelling at you right now, but it'll fix itself here in a moment. So let's do first name, string, last name, and int grade. So take notice there. Like I said, it fixed itself. So what that means, student is an object. It is a noun, much like what we did in Visual Basic. In Visual Basic, you had the nouns like the buttons, the sliders, the checkboxes, things like that. And then you have the adjectives, the properties of the noun. So first name, last name, grade, those are all adjectives that describe the student. So this is like a template or a blueprint for what you're going to create, what you're going to instantiate in the main function. So for the moment, we'll not worry about the functions. Let's just go down here and say int main. We have the variable type. It is a struct, but it's still a variable. It is capital S student. And then just like any other variable, it has the type and then the name. So let's give it a name, something generic like S1 for student 1. Later, you'll learn how to initialize that, just like when you say like int x equals 5. We'll learn how you can do this on one line, but for now we're going to do it separately until we kind of ease into it. So now you've instantiated the noun. You have the object type and then the object name. And so now we have to set the properties. S1 dots, and then again, in Visual Studio, like in Visual Basic, it's nice because it pops up. S1.firstName equals quote, because strings are words, phrases, sentences, paragraphs, characters, alphanumeric. They're in quotes. And so let's just give our student a name. Let's say Amy, and then S1 last name equals, I don't know, how about Johnson? And then our Amy Johnson, the student, is in 11th grade, let's say. So what we do is we instantiate the object, and then we come up with the values that each of the properties of the object are set to. So just no really different than a variable. You can think of the dot operator, that little period. On the left of the dot is the noun. On the right of the dot is the adjective. So the dot can be thought of like an apostrophe. You're saying, what is S1's, apostrophe S, first name? What is S1's last name? And so on. And so, again, we could have covered this in class on the first day of class this week, whatever it was, Monday or Tuesday. And so from here, we're going to look at how you can do this with functions. If we were going to do this in the main program, you just say like cout S1 dot. I mean, again, it's no different really than doing a variable. Just have that extra part of it. So to make a function, I'm going to put a function below the struct definition, but above the main, because student is defined here, And so if we put the function with the parameter student above that, the computer wouldn't know what a student was yet. So we put it down here. I'm going to make something pretty simplistic. I'm going to say like void print students. And as a parameter, I'm going to say send in the variable type, the struct student. Remember, the prototype up top, you do not put in any extra stuff, like you don't put in the other parameter name and whatnot. It's just the prototype. It's the return type, which in this case is void, so it doesn't return anything, the function name, and then in the parentheses you have the parameter, which is student. When I call the function down here, remember it is a void, so we don't print it, we just say it. We don't use a cout, just say it. What is the specific name of our student variable? In this case it is S1. And so we put that down there. And now we go and code our actual function definition. A typical way of keeping these generic is you put the variable name as a single letter that is the lowercase of the struct name, like student S, date D, time T, rectangle R, circle C. You probably know what I'm getting at. And so now in this function we can print this however we'd like to print it. So we decide, do we want to print last name comma first name? Do you want to print first name last name? Do you want to put is a blank grader, is in 11th grade, is in grade 11? Like, we decide that. We are the creator of the function, so we dictate how this is going to look. So in here, if I say I'm going to put the student's S dot, because remember, doing the generic version, last name, comma, space, quote, S dot first name, and then, in the quotes here, we can put something like is in grade, and then S1 dot grade, or not S1, S dot grade, sorry about that, and L. Very straightforward. If I run this little guy quick, you'll see it says Johnson, comma, Amy is in grade 11. Yay! And so that's really all there is to it. It's not terribly different than what we would have done with other variables with functions, or even arrays with functions. You send in the type into the parameter in the parentheses of the function, and then in the function call you put the actual variable name, in this case S1. You of course can do other things with this. You could create other functions. You could create overloaded functions. Remember, an overload function is when you have the same name function with different inputs. So I could have like student S, comma, a Boolean that says true, false. Do you want to print out their grade level? We could also add things to the struct. We put in what is their birthday. But birthday itself, birthday could be a struct. And so one of the things we'll be learning coming up soon is how you can compose structures together. So date, for example, would contain information on the month, day, and year of your birthday. You could make a struct out of that for birthday. And then inside of student, you could put, back up here, you could put something like date, birthday, date, enrollment date, things of that nature. So structs are really a powerful tool that you can use in your programming, and we aren't going to stick with just structs. We are going to segue into something called classes, which is the whole basis of object-oriented programming. Object-oriented programming is what we're going to focus on for the latter half of the year, not just in C++, but also when we transition to Java, because in Java, everything is a class. And in fact, if you go back to our Visual Basic experience, you will notice that the very first line of code is public class form 1. So you were using classes without even knowing it, and structs are sort of the training wheels to get you ready for classes. Because there's one big glitch with what we have here. We'll talk about it soon enough. To be continued, Dun, 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 dun. All right, take care, guys. Thanks for watching.